Okay, so below is a scatter plot showing the relationship between obesity rates for 1990 and 2010 for 26 countries listed in a data sample. So we're going to do a little bit of this in our next topic, where this is actually a scatter plot. And what they're going to do, and we will do all the other stuff with it, but what happens is we will create an equation to represent the relationship that's going on between these two things. So if you have a look, here's the equation that they're giving you. So they can predict the obesity rate in 2010 by using this equation here. Now, so you can see that, can you see this is obviously like our y-axis, and this is our x-axis, and here's our formula where we've got y equals a plus bx, okay? So there's the formula, but they're using all the variable names. So just for those people new to the class, a is remember a straight line is normally this pattern. Yeah, we know now in general maths, we no longer use the letter M. We use the letter B for that. So the slope, so can you see there is the B value, and it's still the same thing. So still the gradient, the slope, and instead of using the C, the letter C, they're actually using we use the letter A. Okay, so that's the difference, but they're still the same thing. So the A is the y-intercept, so A is the y-intercept, and B is, we use the word slope a little bit more than we do gradient, but it's the same thing. Okay, so all right, so now they're asking us, this is equation, so here's a few questions we've been given. What is the y-intercept, so the A value? So we just need to read off this, and we just say 8.1. Now, because the obesity rate was measured in percentage, we'll just say 8.1%. What is the slope? So what's the slope? What's the B value there? We just write 0.93. That's fine. Now, they want us to draw this line. So really what they want me to draw this equation on the graph, 9.3x. So they want me to draw this straight line up on this graph here. Okay, so the first thing we've been doing is we might get the y-intercept, which is the A value. So we can see the A value is 8.1. We'll just double check that this axis is 0, which it is. So you can go up and you're going to mark your first point of 8.1. So I'm going to say roughly there. So I'll just change that. All right, so there. So I'm saying that's 8.1. Okay, now I need another point so I can draw this straight line. So what I'm going to do is I'm going to use this 30 and pop it into the formula, because this 30 is like when x equals 30. So when x equals 30, I'd have y equals 8.1 plus 0.93 times 30. Okay, so we'll do that on our calculator. So I get 36. Yeah? So you go up here, I'm going to say roughly 36. As long as you're in the rough estimate, and just to double clear, we'll write a point down. So we said when x is 30, y is 36. Then you grab your ruler and you join those two crosses together. Okay? And there you go, you've drawn that equation on that line. So this is big in year 12. You're going to have to do this a lot, so that we're going to practice this. So just quickly, because it's 0, you can say we subbed in x equals 0 there. So really we said y equals 8.1 plus 0.93 times 0, and you'll get 8.1. Okay, so let's do this another one. So we have an evening congestion level, and it's getting determined by the morning congestion level. So this is still going to call us our y, this is still our x. So if you look here on this equation, we've got y equals, there's my a value, there's my b value, and that's my x. So really the equation, if we're just using x and y, would look like this, plus 0.922 times x, okay? But obviously it's important to use the variable names, and that's why they're doing that. Okay, so what is the y-intercept in this case? We can see it's the 8.48, and it was percentage again. That was the units they were talking about. They were talking about percentage. I think this is traffic congestion. What is the slope? So they're just checking that I can read off those values, which I can. And now it's, once again, we need to draw this line onto this graph. Now this is where we need to be careful, because this is not the y-intercept. See, they're starting the graph at 35 down there. So what you're going to have to do is you have to sub x equals 35 into the formula to find out what the point is. So it'll be 8.48 plus 0.922 times 35. So I'll do, all right, so I get that to be 40.75. So up along this line, along here, this is when x equals 35, I get 40.75. So it's roughly there, okay? So I'm drawing it around on the 40, nearly on the 42, okay? So then I need 2 points to draw that line. So I'm then going to do the same thing, but using the 70. So 0.922 times 70. So I put that into my calculator. So I got that one to be 73.02. So I go up here to 7123. There's my other point. So I might write those points down. So I had 35.41 or something. And then I had 73. There you go. And then you get your ruler and you join your two crosses, and there you've drawn that equation on the scatter plot.